Hello, welcome to this webinar of EuroSTAR, titled Going Cloudy? How to Test Software as a Service. My name is Kees Blokland and I work for Poltech, a test service provider in the Netherlands. Together with my colleagues Jeroen Mengerink and Martin Pol, we developed an approach for testing cloud services, which is published in this book. A summary of the book can be downloaded as EuroSTAR ebook from the EuroSTAR website and also from the Poltech website. At the end of this webinar I will show you the references to the book for a second time. The cloud. There's not so much we not do in it. But where do we come from? Consider a traditional setting where an organization is housed in the building and everything is contained in that building. I'm in the building, my computer is in the building, the network is in the building, the servers are in the building, my data is stored in the building, and the IT maintenance people are also in the same building. For the email, web surfing and file transfer, we leave the building. Well, the data is leaving the building. The traditional all in-house situation, though, has a number of issues that become more serious over time. Take the data center equipment, for instance. On average, 80% of its capabilities is unused. Organizations are having more and more problems with the high capital investments in equipment that is required to accommodate peak loads and future growth. And growth there is a lot, such as the constant claim for more storage and the always growing requirements for faster hardware. Organizations are faced with new requirements too. There's an increasing criticism on power consumption, with the question behind it, is your organization green enough? And the need to support the new world of work and bring your own device phenomenon. Recent technological innovations and developments can cope with most of the issues. For instance, virtualization to increase the hardware exploitation and by that decrease in the capital expenses. The use of standard software for commodity services will further cut costs, and service orientation combined with high bandwidth internet technology will enable the delivery of services at any location using any device. The new technological possibilities and the search by organizations to get solutions for their issues give rise to the following trend. IT goes into the cloud. But what is the cloud? What characterizes cloud computing? We use the cloud computing definition of the National Institute of Standards and Technology. I will give a short explanation of the essential characteristics of cloud computing according to NIST, because these give rise to many specific risks that are introduced with cloud computing. For instance, on-demand services, which means you can get what you want at the time that you want it without needing help from anyone. Example, you can go to a website and have an IT environment in the cloud up and running in minutes. Broad network access. A service is available anywhere in the world and with any capacity that is needed. Resource pooling means customers are sharing supplier resources, and this provides higher cost efficiency. Rapid elasticity, like on-demand services, more needed via a simple manual action on the internet, or even automatically you get more or less capacity. Example, Dropbox. Measured services, pay per use, only pay what you use. That's the mechanism. Cloud computing deployment model determines with who the resources are shared, and I will not go into more detail there. The main focus in this presentation is on software as a service model. This is where the cloud supplier provides a full functional service, and the customer only needs a device to get access to the cloud service provider, and the cloud service provider is responsible for everything else. The cloud, what does that mean for testing? The answer to this question starts with finding an answer to another question. What are the risks of using cloud computing? And there are all kinds of aspects in the cloud computing that come with risks. And we made an inventory that identified 143 risks. And we grouped them into 7 risk categories. These 7 risk categories. Let me give a few examples of cloud-related risks, starting with performance risks. Traditionally, you have the question, is the application and its environment fast enough considering my expected usage? Usage that is modeled into an operational profile. In the cloud, there are other users too. Remember, one of the essential characteristics is resource pooling. Now, the risk of insufficient performance not only depends on my operation profile, but it also depends on the usage of other customers that share the same cloud service resources. If many customers are having peak load at the same time, this will introduce a high likelihood of performance issues. A security example. Traditionally, everything is in-house, operated and controlled by your own trusted people. In other words, it is safe. In the cloud, the user gets access to the service over the web. Broad network access, And by that, there's a risk that other people penetrate the service and get hold of or even change your data. Another security example. In many organizations, people use mandatory standard desktops, configured with security policies like an automatic screen lock after a timeout. But more and more people want to use their own device, because of which organizations decide to use cloud services. Using own devices introduces security risks. Let me give an example. Show of hands, please. Who has an automatic screen lock on their smartphone or tablet that needs to be unlocked with a PIN code? Of course, I cannot see you, but based on experience in other audiences, I guess that not all of you have your device secured with this simple mechanism to prevent others to access your data or the company's data on your device. There is no control over that. An example from another risk group. Within the organization that I used to work for earlier, my colleague Vincent of the IT department took care of patches, updates and fixes. He planned the updates, for instance, during the weekend and informed all users about it. So we knew that we might run into some issues when coming into the office at Monday morning. But now, consider your smartphone or tablet. I own an iPhone and the update counter of the App Store shows 15 after some time not updating. When I check the release notes of a typical update, it says various bug fixes, including an occasional crash and missing scan button. Do I need this? Don't know. But what's the point? What choice do I have? Not updating? I may reach the point that I run a version that's too old to work. So I click update. Then something else happens. I get a pop-up message that the terms and conditions of the App Store has changed. And whether I agree or not. There's actually a button no, but again, do I really have a choice? No means no updates at all anymore. So again, I accept the updated terms, not knowing what has changed, by the way. And this is what happens with cloud services. Updates happen all the time without the possibility to not having it. What's the risk? For instance, that users are confronted with changes in the service, not knowing how to cope with it. A well-known risk example in the area of legislation deals with this question. Where is my data? Before the cloud, this would have been an easy to answer question. Somewhere in-house, in the data center, with access restricted only to well-known maintenance people. But what about in the cloud? Again, a request for a virtual show of hands. Who of you uses Google Docs? Something like that. Well, so was a European local government. They started to use it to enable easy sharing of documents to enable government employees to work at home. Until someone found out that they were seriously violating European rules. And these rules requires guarantees that all privacy-sensitive data stays within the borders of the European community. And at that time, it was not possible for Google to provide these guarantees, because the data is stored in different data centers in the world, part of which were outside the borders of the European community. So, in the cloud means my data is somewhere, but I need to know, is that okay? What legislation risks do I take there? So, that were a number of examples of cloud-related risks. So now, how to mitigate cloud-specific risks with testing? We determined test measures for all 143 identified risks. Certain risks can be mitigated by traditional activities like testing and reviewing. For other risks, we had to find additional measures to mitigate, for instance, performing audits, performing proof of concepts, and executing simulation. So we took all these measures with us, and again, we organized the test measures in the following groups, and I will give examples later on. But first, the next step is to link the risks with test measures. For instance, if you look to the various performance risks in the list, they link to test measures from 4 groups. The number of security risks is overwhelming. They link to a large variety of test measures. So, for each of the individual 143 risks, we identified 1 or more individual test measures that will help mitigating each risk. Part of the test measures will be executed during the selection phase, when the cloud service has not been chosen yet. Other measures are executed when the service is up and running in production. But most types of test measures are executed in the implementation phase, when the cloud service is already available, but not in production yet. I will give some examples of the numerous test measures that we have described for covering all the cloud-related risks we have identified. So let's start with testing during selection. The earlier risks are mitigated, the better it is. Early involvement is key, nothing new there. One of the first actions that can be taken is making sure that the selection criteria are complete and specific enough. Complete means including cloud-specific risks, for which I provided a number of examples earlier. Specific means, is it clear how to verify that a criterion is met or not. Cloud services are not bought but are rented, which means that we have an important advantage. We can use it for a limited of time for every evaluation with low cost. This enables the execution of a proof of concept. That means using the candidate cloud service and try the intended user processes to find out if it works, or finding out that there's a blocking issue, which means we have a showstopper for selecting this service. In this way, risks are mitigated early before the final choice for a cloud service is made and the implementation phase is started. Mitigating risks by applying test measures is a typical job of a test manager. It's strongly recommended that someone with the role of test manager participates during the selection of cloud services to help mitigating the risks. Implementation means the selection has been done, but the cloud service is not in use yet. It's now time to test to verify that everything is in order before starting to use the service. Blocking incidents found during implementation phase need to be solved before production. In an extreme situation, a showstopper could cause that selection decision needs to be reconsidered. Many of the test measures are similar to testing in traditional, non-cloud software. By tweaking, tuning and combining known test approaches, a part of the cloud-specific risks can be mitigated. But there are also risks that are not regular in the traditional testing scene, which needs new test measures. Let's look through some examples of old and new test measures applied in the cloud context. Load testing, for instance, is more or less standard these days, especially if there are many users involved and fast performance is business critical, like a web shop. A load test is based on an operational profile, how many people are doing what at which time. This is put in some automated tool which tests the software against the profile. If the test passes, the risk of insufficient performance is covered. But what if the software runs in the cloud? The test with the tool can still be executed, but the problem now is the operational profile needs to include also the use of the service by all other customers on the shared cloud resource. But in general, there's no knowledge about that. So the solution is to execute the load test in real time. That means test the various loads at the moment they are expected to happen in reality. If there's always a peak load in the morning, execute the test in the morning, assuming that other customers are having their typical everyday uses as well. This is the closest you can get to reality. But there's no guarantee, though, that the load on the service by other customers stay the same over time. So it is necessary to repeat a load test regularly in production. Traditionally, load testing is followed by stress testing. This is to verify that there is sufficient room for growth and to see what happens when the load peaks to extremes. Does the performance degrade, or does the system break down completely? Finding stress limits of a cloud service is not an obvious thing to do, though. Stressing a cloud service for a start cannot be done right away, since it may affect the service to other customers. And the terms of conditions may pose restrictions on going beyond normal usage of a cloud service. So is stress testing not applicable to cloud service then? Well, yes, but in another form. It's testing elasticity. Rapid elasticity is a mechanism that provides the customer of cloud services with the opportunity to accommodate growth. And we combine load testing with elasticity testing, and that can be done as follows. First, we start with the load that is significantly below the current maximum capacity, for instance, the maximum current users of the service. And then the load is increased step by step, like a regular load test. The number of users, or virtual users, since the load is generated by a test tool, so is increased step by step. In this example, the maximum capacity is 100. 100 is a boundary value that will be tested by the three load values, 99 users, 100 users and 101 users. Around the boundaries we check on the following aspects. Are all users getting access and acceptable performance? Is the maximum capacity automatically adjusted when the 101st user is added to the load? Are there no glitches in the functionality or performance when the capacity is adjusted? And is the new capacity correctly and transparently charged by the cloud service provider? The second part of the test is similar, but now the load starts high and is increased to test that the service capacity is also decreased when the number of users jumps below 101. Now, a functional testing example. Multi-platform testing is a common test goal. Does the website work on Internet Explorer, but also on Safari and Firefox and other browsers? For cloud users, they expect that it works with any device on any platform. So, multi-platform testing is typical for cloud services too. But what used to be repeating a small subset of functional tests on some other browsers is exploded due to the high number of permutations of device platform combinations. This gives a first idea about the size of the testing challenge. And this is another view on it. For most organizations, it's not feasible to buy all the device types and the devices. Fortunately, you can find companies on the internet that can do multi-platform testing for you, because they buy all the stuff and you can hire them for testing. Apart from the variety of brands, you also have to deal with the differences between the device types. It's not sufficient to run a small subset of functional tests on the different device types. If you take Dropbox as an example, different functions are provided using a browser on a PC, using a browser on a smartphone, and using a native app on the same smartphone. This actually requires that dedicated tests are defined for different device platform combinations. So, a lot to test. For those of you who are working in the financial scene, some of you may have tested requirements that were imposed on the software because of legislation, such as Sarbanes-Oxley. So, the law can be part of our test basis. A set of requirements that needs verification or validation, if you will, by testing. In the cloud, we have the situation that basically everybody has to deal with requirements from the law, namely the privacy legislation. Personal information in the cloud, like information needed for user administration, is subject to privacy laws. Compliance testing is necessary. How to do that? How to test on compliance? In this example, we need to check the security level on the data, all the way to, in and from the cloud. So, if we start from our device and virtually follow the data over the internet to the cloud service provider and into the premises of the service provider, we check, is the data sufficiently protected everywhere? European law requires data to stay within the boundaries of the European Union. Is this the case indeed? If not, are there additional measures and contracts in place to guarantee the data protection outside the European Union? If not all requirements are met, the service cannot be used without violating the law and should probably be abandoned. Point is though that politics are trying to catch up with the growing capabilities of cloud computing and update cloud-related legislation to facilitate further deployment and growth of cloud computing business. In other words, what's not possible today, maybe tomorrow. Testing during implementation is convenient in the sense that the service is not in production yet and no users are bothered by it. But we also realize that positive test results from test measures during the selection and implementation phase do not guarantee that these results stay valid forever. Due to all kinds of reasons, things continually change. And these have origins like the cloud service provider that develops and updates the service, other customers that intensified their use of the service, more intensive use by yourself, and changes in the user processes, and there are many other reasons. Unfortunately, it's not very likely though that each customer is always aware of or informed about the changes. So continuous regression testing is required. And you do this to detect the changes and to check the impact of the changes. And it's best to do this end-to-end to have the best chance to discover all changes and to monitor the full impact on the user processes. And it should include functional as well as non-functional tests, like we discussed on performance. So, what did we learn? I showed you that various cloud-related risks are introduced when cloud services are implemented. And we have identified a large variety of test measures to mitigate. We identified individual test measures for many individual risks. And we also saw that testing starts early. Already during the selection phase, a number of risks needs mitigation. The scope of testing is widened. It's not only performance, functional, but many other activities. And testing continues in production. So I promise you to show the reference to the book again. Again, the summary can be found in the EuroSTAR ebook, so please refer to the EuroSTAR and Poltech websites. And, well, thanks for listening.